This is solid mechanics course, EGME-331, and we are going to review the topic Poisson's ratio. So what's Poisson's ratio? When a material is loaded in one direction, the material does undergo deformation in all the three directions. So whether it's length, height, or the width, when you apply the load in one axis, the other two axes also subject to strain or deformation. Naturally, when one side is elongated, the other two sides compresses. And on the other hand, if you compress one axis, the other two sides expands. So what we see here is two kinds of strains. One is a lateral strain and another one is called the longitudinal strain. And as long as the material is elastic and homogeneous, we could relate these two strains. The ratio of the lateral strain over the longitudinal strain is what we call as the Poisson's ratio, which is a constant and which is a property of the material. This constant was first identified by Simeon de Poisson in 1811. Poisson's ratio is denoted by the Greek symbol nu. If you see the equation here, you could see a negative sign that indicates that the two strains are in opposite direction, right? When one expands, the other one contracts, or when one contracts, the other one expands. So because of that, we use the negative symbol to make the Poisson's ratio eventually positive. Naturally, the Poisson's ratio concept is only applicable for uniaxial stress state. That means we are talking about tension or compression. And typical values of Poisson's ratio are between 1/4 and 1/3. And considering the volume of the material being constant, the Poisson's ratio could only take a largest number or value of 0.5.